In today's video, we're going to talk about the command pattern and what it is and how to implement this in Godot. And we're going to do so by building this simple scenario where we can queue up commands for our little awesome Godot icon and also be able to undo them. All right, welcome everybody. So in this latest video, I want to cover a command pattern, and this is kind of going to be a new series. I'm going to cover multiple patterns in the future. The first one I decided to start with is one that I actually don't use a whole lot. It's the command pattern. What the command pattern is it encapsulates player actions into objects, allowing for easier input handling like undo or redo functionality and action queuing. So you could think of something like some of these examples below. An obvious one would be like the action time battle system in like a Final Fantasy game where actions are queued up and they happen in the order that they were queued up. One of the benefits of a command pattern is that it decouples that input execution or the calls from the actual execution so that you can keep that sequence going. It makes the code a little bit more maintainable and scalable, and it kind of keeps some of the classes and the code that has to manage the commands down to very minimum, okay? Other examples I think that are interesting, you could use it for input management if you have like a fighting game and you want to manage your combos and detect button inputs and things like that. In general, and like we'll do in this little demo project today, undo and redo becomes a lot easier when you have this kind of pattern implemented because you have a list of all of the commands that have been done, and then you can just, as you execute the commands, you can put them in an undo list, and then if you need to undo, just reverse it. You can queue up abilities like we've mentioned, make a replay system. RTS games probably implement command pattern all over the place. And so what this command pattern looks like is it consists of a few things, but generally you have a command object. And what we're going to build here in Godot is just a generic node that's a command node. And then we'll create new nodes that extend from it. And each command object is responsible for knowing how to execute the command. And if you need undo, then it should also know how to undo that command. And those objects then get invoked by the player. And this could happen through the UI, through button presses. And so there's usually an invoker, right? This could also be known as kind of like the client or the source. And when the invoker sends a command by clicking a button, pressing a hotkey, whatever, then it sends it down to the command manager. So you'll have some kind of object that will take the commands and it will help maybe enqueue them or schedule them, right? And then dispatch them in the correct order. And this would also be the place where you would want to implement any undo function or tracking, So when you execute a command, you could add it to an undo stack. And then that command will get sent to a receiver. And this is typically also known as the target object. What is the command going to change or control in the game? And so in the example we'll build today, it's going to be like a little character or unit that we can command around the map. And the receiver typically receives and is controlled by the command. And it may or may not handle. So there's also the concept of a handler with your command pattern. The handler is the event or the function or the object that actually executes all the code. Now there's three common ways, or maybe two common ways that the handler is implemented. And one of those is it's a part of the command object. Okay, and so we're going to actually build it that way in our example today. Sometimes the receiver or the target is the handler and has the code to handle the commands. Okay, so maybe when you get a move command, for example, then maybe the receiver, the unit, has a move function that the move command knows it needs to call, something like that. And sometimes the handler is in a completely different system of the game, and that's perfectly fine too. As long as each command has some kind of handling code associated with it, it doesn't really matter too much where it is, as long as it's clean and organized and easy to understand. And so if we look at this simple diagram, what we're going to build today with this simple unit command system is it's going to be really boiled down version of this. And so we're going to have a unit command object, and we'll make two different commands. We'll have a move command and a spin command because I just something easy. And so that command object will contain the command, but it will also be the handler and handle the logic for that command. And then we'll have what I'm calling a commandable unit. And so I'm going to wrap the rest of the functionality into this unit. So the unit will handle invoking the commands. So it's going to do handle the input events. It's going to manage a command queue as well as an undo queue. And it's also going to be the target of each command. Now, this is maybe a slightly unconventional way to do it, but I think it'll be nice because it's a very simple set of code we're going to build. And then you could easily abstract and pull some of these functions out and put them into a global, for example. If you had multiple units that you wanted to be able to use this command with, you could almost take this example and extend it to do multiple units quite easily, right? You just have to separate a little bit of make sure that your autoload script or whatever it is, that singleton that is maybe managing the units, has a way to send the command to the unit that it is attached to, and things like that, okay? So that's what we're going to build. If that sounds interesting, stay tuned, and I hope you guys enjoy it. All right, so let's start looking at how this actually works. And I want to start by looking at what our command object looks like. So here's the command object. You can see that it's a class that extends a node. And I've chosen to make my command class extend a node for a very specific reason, actually. You could make this extend like object. I could say extend object. But the object lacks some functionality. We're going to be using tweens in this. And so I want to be able to have the node so I can have access to things like that. But even still, if we want our command classes to be able to access things within the Godot system, that the base type of object is not going to give them access to certain things. So for example, if you need to access the scene tree, you can't do that from an object, but we can from a node. And so for that reason, I just make it a simple node. And then we'll just create instances of these. We'll just basically be creating nodes and adding them to our unit as we play. Each of my commands is going to have a command name, which is really done for the sake of demonstration because we're going to display the name. So you don't really need that. The unit is very important. You can see that each command is expecting to keep track of or be able to keep track of the unit, which is a command unit. And we'll look at the command unit code next. And then you could use a signal. I added a signal here, and I'm actually going to move that up top because that's where I like signals. But I'm not actually going to use it in the demo today, but we can go ahead and emit a signal when the command is completed. And then if you have other systems that are waiting on that command, then you'll know when that command is done. But our unit will be able to know when they're done by virtue of the way that we build this system. And that's done with each of these functions. So you can see I've got an execute and an undo function. Very straightforward, right? What happens when we receive and execute this command? And how can we undo the command? You'll notice one thing about these, though. They return a Boolean, both of them, as opposed to void, right? Usually we don't write anything, or we write return void. But in this case, we have them returning Boolean, and they're returning true by default, which we'll kind of stick to. And the reason I want that is because by adding this return Boolean, if we add and await something within this function, like wait 10 seconds, and then it returns true, then our unit or our command manager that's executing this, we can actually await the execution to be completed by simply awaiting the execute function, okay? So that's why it's going to return a value, just so that it becomes easy to make asynchronous. And if you have commands that need to be executed instantly and there doesn't need to be a delay, that's fine. It'll still work. You just have to return true at the end of them, or false for that matter. Okay, so that's our command, our base class for our command. So next thing I'd like to look at is our unit, our command unit. And this script is actually attached. I've got an example scene here, so you can see this really simple scene. This is going to be our unit, the little Godot icon. I know I got lazy on this one. I didn't want to have to worry about animating stuff, but this unit has that one script attached, the command unit, okay? As I mentioned previously, our command unit is going to be capable and responsible for handling a lot of stuff, okay? So just looking at him here, it extends node 2D, okay? So that we can move it around and whatnot. It has a single signal, which is commands changed. And so we can emit that signal anytime our commands have been updated. We have two different arrays, a command and an undo queue. And you can see each of these are arrays of our command class. And obviously will be used to keep a list of, a queue of the commands that we need to dispatch or execute, as well as the ones that have been completed so we can undo them. And then a simple Boolean for awaiting execution. That's just going to help our code be a little bit cleaner. And looking here, I've got an unhandled input function, and this is where we're going to invoke the commands to our unit. So we'll just listen to key presses and mouse clicks in here. And while I'm speaking about it, let me just pull up my project settings and go to my input map. And you can see you can get clicks without the action, but I like to be able to use the input, event.action syntax. So I've got a click and a right click, which are, bound respectively to the left and right click, and a spin action, which is the S key press on the keyboard. Okay. So we're going to be listening to those input events and invoking and queuing up actions. And so that handles kind of the invocation, the invoking part of this command pattern. And then down here, you can see that we've got just a few functions. I've got this little explanation, but this unit is going to, as we said, it's going to handle its own command management. So it's going to take in commands. So it would add them when it takes a minute, meaning it would add it to the command queue. It will execute those commands, and it will also provide a way to undo those commands. Okay. So you can see I've got 3 little functions in here to help with that. Now, I'll just restate again that this kind of a command pattern, condensing it into one script, is not really ideal for a large project, but for what we're doing here, I think it will clearly illustrate how to begin implementing it. All the code from here down, you might want to move to a singleton, some global script, maybe an autoload script that handles the command management. And going back to this scene, I've got this example scene I've set up. You can see it's a basic 2D scene. And I've got my unit in here, and when I've already shown that we've got this script attached. And then I've got this UI. Now, you don't necessarily need the UI. I'm going to use it mostly for demonstrative purposes here within the project, within the demo. But this UI contains some information here about how to run the demo. And then I've got a section where we're going to display our command queue as well as our undo queue. And then there's an undo button. And so if you wanted to implement an undo button, then yeah, you might want to add a UI. So this undo button actually, and this command UI that I've got here, you could use this UI to invoke commands as well. And in fact, we will invoke the undo command, obviously, when we click that button. Okay. And so I'm not going to review this script in detail because it's not required to make this work. But if you wanted to, you could look at this script and see how I've set it up to be able to help. It's going to connect to the unit when its commands changed, and it's going to handle undo button pressed, things like that. Okay. Okay. So let me run the project. It's not going to do anything, of course, at this point, but you can see I've got my little guy in here, and clicking on stuff does nothing because we don't really have any code here. So we're going to build 2 simple commands. We're going to build a spin command. We'll do that one first because it's the simpler of the 2. And then we'll build a move command. And as we issue the commands, they'll appear in the queue. And once they've been handled and executed, they'll get moved to the undo queue. Okay. And the reason I want to start with the spin command is simply because it's simple. We'll go ahead and create a new script under my scripts folder for this. So I'm going to create a new script, and I'll call it command_spin. And we could say here where it inherits, we could say that it inherits command. There we go. As long as you've got that class name on your command script, it should work. So I'm going to create that. And if we look at the command spin, it didn't give it a class name. I want to do that. I always just do that as a preference. But this also will make it so that it's a little bit easier to differentiate what kind of script you're running in other parts of our code. Okay, so there we go. We've got our class name. It extends a command. Now let's just revisit this command script real quick. We already have these built-in variables, and we're not going to assign the unit in here. We'll do that when we invoke the command. But I do want to update the command name. And the way I'll do that in this example is I'm just going to simply say, I'm just going to have our ready function in here and just say that the command name, oops, not command completed, command name equals spin. So I'll just give it a new string for that name. Okay. And then obviously we need our 2 functions. We need our execute and our undo. So I'm just going to set those up. And remember that these return a Boolean, not void. So we need to make them return, and I'll just make them return true by default. I'm going to just copy that. And there's our undo. Okay. So what do these functions need to do? The execute is going to spin the object. We'll go ahead and create a tween in here. And if you haven't worked with tweens before, you just create a new tween variable. So we'll say tween equals, and then there's a create tween function that we can call. Okay. And this is one benefit of making sure that our commands extend from a node, so we have access to that. And then we can define what the tween does. So we'll say tween.tween property, because we want to tween the rotation of our unit to make this spin happen. And what you provide, you can see here with the little tip, we need the object that we're tweening, the property we're going to tween, the final value of the tween, and a duration for that tween, okay? So the object is going to be the unit, which is a part of our command. And then the property we want to tween is we want to tween a rotation. And I'm going to tween rotation degrees. And you can see it's kind of giving me the hint that that's an option. So this way it's, between 0 and 360 as opposed to radians, I believe is the default in Godot. And then the final value, we're going to simply just say 360. So he'll do a spin in a full circle. And then for the duration, put half a second, 0.5. Okay. And then what we can do here is I'm going to say await tween dot finished. Every tween has that signal when it's complete. And then I'm going to go ahead and just set my rotation just to make sure that this doesn't mess things up. And say unit dot rotation degrees equals 0. That won't be a noticeable thing, right? Because 360 is the same as 0, with the exception of the number. And then we'll go ahead and return true. And so that's how we're going to execute that simple function. Now, how are we going to get this command? How are we going to queue up and create or invoke one of these commands, right? I think everybody's probably wondering that. So if we go over to our command unit, we said we're going to handle that within our unhandled input. So let's go ahead and look at this. We'll just start with checking our input event. So we'll say if event dot is action pressed. And in this case, I'm going to choose spin, right? That's one of the actions I had set up. So when we press the spin action, then we can do this. Now, in order to create a new command, we don't have to like instantiate a scene to have one of these. We can actually create one of these nodes just right here from our script. So we'll say varc equals, and then this is going to be one of our command spins, right? So we'll just type command spin like the class name dot new. Okay, so that'll create a new command spin in memory, and then I'm going to go ahead and just add this command. And there we go. That's all that is needed for me to be able to create one of these, right? I'm going to just do that, and I'm going to add the command. And then let's obviously set up our add command. So we're going to do a little bit extra here in the add command function because there's a few things that need to happen. So first thing is let's go ahead and append this to our command list. So what do we call it? Command Q dot append. And then we'll just say C, right? Because you can see in our add command function, it's expecting a command. And append just adds it to the end of that array, right? Okay, so pretty straightforward there. And then I want to add this node to the scene tree somewhere. So I'm just going to say add child. Okay, which should add it as a child of this unit. And then we need to do a little bit more because we need to identify what the unit is within that command. Because if you recall, if we look at the command script, it's got a unit. Okay, so we can assign the unit here. We'll just simply say c.unit equals self, right? Because the unit that we're expecting is this command unit. And then last but not least, let's go ahead and call execute command, or execute next command is what it's called. Because we're just a couple steps away from being able to actually test this out. So let's go down to our execute next command function and set this up. Now, what we need to do here is I'm going to go ahead and emit a signal that this is just for my UI, because my UI is listening for this command's changed signal. So I'm going to go ahead and emit it. Okay, so you don't need that. That's just for me. And then I'm going to say, I'm going to grab the first command from the array. Now, this seems silly because right now, the sequence that we're going down, we went from 0 to 1, and now we're going to grab the first. But obviously, if you queue more commands, then it makes a little bit more sense to grab the first one, right? So we'll start by saying variable c, which is going to be of type command, equals. And then what we'll do is we'll get our command queue, and we'll say dot front. Okay, that's going to grab the first one. Now we could use pop front, which would not only get the front one, but pull it from the array. And if these were going to execute instantly, that would be okay, because we could do that. It would pull it out so it's no longer in the array, and then we would add it to our undo array. And in fact, we will use pop front, but the reason I'm not doing it here is because we're going to wait for this command to finish. And so I don't want to pull it from the array just now, okay? Your mileage may vary with that, and you may want to change it. But we're going to go ahead and grab that that command, and then we're going to await the command's execute function. Okay, and what's nice here is we know we have a command. We don't know what type. It could be spin, it could be the move command we're going to build, or maybe it's attack or jump or some other command that you add in the future. This code only cares that it is a command, okay, which is really nice. So we'll just await it, and let's just go ahead and save it and run and see if this works. Hopefully, if we hit S, it should spin our guy. There we go. And I can keep hitting S. Now you can see that our command queue has grown. And we would like these spins to move to the undo queue when they're finished. And you can see if I just hit spin a bunch of times, it's not working very well. The reason it's not working very well is because we need to make this function recursive. I put that in a little note here, right? Once a command is completed, we need to try and do the next one. And so what we'll simply do is after this await, we can say execute next command, just like that. And so we're going to recursively, this function will call itself. You wouldn't want to do execute next command if there wasn't an await here. You'd probably want to have some other way of queuing them up, okay? Or maybe you would, but you got to be careful that you don't make an infinite recursion loop. Okay, I'm going to go ahead and just run this one more time and see. Now if I hit S like 3 times real fast, oh, that's not working very good, is it? And I think the reason why is because when we're adding a command, we're calling execute command. So this is where we need to come in and say, wait, hold on. It's trying to execute all these commands as I press them, which is great the first time, but not the second time. So remember we had a variable in here called awaiting execution. Let's go ahead and implement this and start utilizing that. So right after right before we grab this command, let's go ahead and put a little check in here. We'll say if awaiting execution equals true. And I'm going to go ahead and add one other condition in here. So this is, we're going to say if that's true, then we're going to return. We're not going to continue running this function, okay? We will want to admit that our commands changed. So anything listening will know that they changed, that we added one to our list. And that's going to let our UI continue to work. But there's another condition where we should probably exit the function. And that's if for some reason we don't have any more commands. Because remember, this function is recursive now. And so let's say we only had one command. It calls it, it waits, and then it calls it again. What are we supposed to do if there's no commands left in the queue? Just return, right? So let's just add a check in there. So if our command, let's see, or command queue.size, oh man, if I could type, equals 0, then we'll return, okay? But then we also, obviously, if we're going to await this execution equals true, we need to set it. So we'll set awaiting execution to true right here. Okay. And then once we're down here and we're done awaiting, then we'll go ahead and set that to false again. So this way, once we start executing a command, if we add more to the queue and it calls execute command, it's not going to do anything, okay? But it will update and notify the game that our command queue has changed. So now if I run this, there we go. I just tapped spin a few times and oh my gosh, I think it's never ending. But you know why it's never ending? Because we're not removing them from the queue. So I think it's still just picking up, okay? And in fact, it's always going to pick up that first because we're just getting the first command. Okay, so a little bit more work to do before this works. So what I could do right now to just get this kind of working, I could show you if we just, instead of do front, if we do pop front. Let's go ahead and run this and hit S 3 times. There you go. You can see it stopped and my commands disappeared. Okay, so there we go. So obviously by just doing front, we weren't removing them. They were never getting removed from that queue. So that would last forever. So what we want to do next is after we await the execute, let's go ahead and remove the command from the queue at that point. And we'll just say, I'm going to remove it and add it to the undo queue in the same line of code. So we'll say undo queue dot append. Nope, we don't want to append because that adds it to the end. We want it to be at the front, right? Because the undo is going to be the opposite order. So we'll use push front. What push front does is it pushes the variant at the front of the array instead of onto the back. And then what do we want to push? We could say this command, but what I want to do is I want to say command q.pop front. That way, this pop front will remove it from the command queue. And then obviously we're going to add it to the undo queue. Okay. So if we run this one more time, we should see some changes here. You can see we've got some undo queue items coming up into our undo list. Obviously undo doesn't work yet, but there we go. Spin, whoop, spin, whoop. My pop sound effects are world class. So there we go. So actually this works pretty good, doesn't it? We're just going to await, turn our awaiting execution boolean to true, grab our command, execute it. Once it's finished, we'll move it to the undo queue, turn awaiting execution to false. And then we call this execute command. So it's going to come through and it's going to update our list. And if we have more commands, it's going to run them. And if not, then the sequence will stop until another command is added to the queue. Okay. Hopefully that's pretty straightforward. And that's a real basic version of this code. You might need to add more logic in there if you need any advanced kind of functionality. Okay. Now that we've built our functioning spin command, why don't we make it so we can undo a spin command? Okay. And so if we go back to our command spin script, what does the undo need to do? I'm actually going to just copy this code here, put it in undo because it's basically the same thing. One difference is we're going to start at 360 degrees and rotate to 0. So I'm going to move my line of code where I set the rotation to the beginning and set it to 360. And then down here where we tween it, we'll just tween it towards 0. And voila. We're still going to await for it to be finished and return true. And then let's go ahead and hook up my command unit. We don't have any code in undo last command, so let's go ahead and build that code real quick. Undoing is going to be very similar to the execute command, okay, but it's not going to be identical. We're going to go ahead and grab this little check to see if we're executing, but we're going to change this because instead of pulling from the command queue, here we're going to be pulling from the undo queue. So I'm going to change that check to the undo queue size. Okay, but we're still going to check if we're executing, then let's wait. Okay, and then likewise, we can say awaiting execution equals true. And then let's go ahead and grab our command. And this is very similar to what we did before, right? We're grabbing a command, but instead of grabbing it from our command queue, we're going to grab it from the undo queue. So we'll just say undo queue dot, and here I'm going to go ahead and do pop front. Okay. And I'll be completely honest. The only reason I didn't do pop front right there and waited here is because I think it was causing issues with my UI updating with that list. So I don't know. You can ignore that if you don't want to. But let's see. Here we go. So when we undo, we're going to go ahead and pop the front from the beginning. I'm going to make the undo a little bit less robust. We're not going to be able to queue up undos. It's just going to undo one command at a time. Okay, you could make it queue up and it would be a little bit more closely matching to that. So once we grab that, I'm going to go ahead and emit the signal where our commands have changed. That way it's going to update my UI. So we'll just emit that signal there. And then I'm going to await the command dot undo. Whoop. Okay, so far it's very similar, right? So we await the undo. And then I'm going to say awaiting execution equals false, plays false. And lastly, The question is what do we do next here? Now, I think there's a slightly more complicated way to handle this, but I'm just going to call execute next command because, like I said, I'm just going to make the undo one command at a time, and then if we happen to have a command queued up in the meantime, it'll go ahead and do that. Okay, but likewise, you might want to build in, in a way to tell which command was added when or something like that. Okay. But there we go. I'm just going to execute the next command. So if we save this, we have an undo in our spin, and we now have code to handle that. So if we run the project, I should be able to spin, and I think my undo button's hooked up. Hey, there we go. You saw it spun backwards. Look at that thing spun. Okay, there we go. So that's how we build undo. Now, obviously, however you manage the code for the undo depends on what you want to undo. It doesn't have to do the reverse action, but in the case of the spin, it's fun. Okay. Okay. So there we go. We've got our first command. Let's go ahead and build a new command. Okay. So let's go ahead into our scripts and let's create a new script. Bloop, bloop. And I'm going to go ahead and have it inherit the command class. And I'm going to call it command_move. All right. Command move. Give it a class name. And we're ready to rock and roll. Now, this command is a little bit more involved. And this command is going to require us to tell the command, like the command needs to know where we're moving to, where we've clicked. And so let's go ahead and add some extra variables that we will track here. And so we're going to have an initial position. Where did the unit begin? This is going to be very useful for undo. Okay, and these are vector 2s that we're going to set up. So that's a vector 2, and we'll just initialize this as vector 2 0. And then we also will need to have a target position. Okay, also vector 2 0 when we start. Now let's go ahead and just do our ready function like we did on our spin command. And here I'm going to give the command a name. All right, that's probably good there. All we really need. So let's set up our two functions, execute and undo. There we go. Now, in this case, what I want to do when we execute this command, I want to store my initial position. I'm going to get the target position from when we click, but the initial position, I don't want to grab when we click because we don't know where the initial position will be. Let's say we queue 3 movement commands. Obviously, we want to wait until this command starts to know where the unit is when it started, right? So that's why we'll grab the initial position in the execute. So we're just going to say initial position equals unit.global position. You could do just position. I'm going to use global position. And then let's create a tween. Okay. And in this case, we're going to tween the position. So I'm going to just, similar to what we did before, I'm going to say tween.tween property. And then the object will be the unit. And we're going to tween the position. And then we need a final value, and that's going to be our target position. And you're probably thinking, Mike, we don't have a target position yet. I know, we will get there. When we invoke it, we'll set that. So right now, we just walk to vector 2.0, but and then we could put a duration in here, and let's go ahead and let's just go ahead and put one. I'm going to put 250. No, I don't. I want to put 1 for 1 second. 250 would be a long time. He'd be moving really slow. Okay, because that's in seconds. I was thinking speed in my head, speed 250, but okay. So once we do this, then we need to await our tween dot finished, just like we did in the undo or in the spin. And voila. Okay. So that's pretty simple, actually. It looks easy, but it's going to get slightly more complicated, which is why we waited, because it's going to have some rough edges I want to polish. Let's go ahead and set up the undo, though, while we're at it, right? I'm just going to go ahead and copy this code here. I'm going to paste it. We don't need to set the initial position because we've already stored that when we execute. So we'll create a new tween. We'll tween to, in this case, the initial position. And we'll do it over 1 second. Okay. And then we're going to await the tween finished, and voila. So if we save this, we just need to go over to our command unit, and we need to set up another condition in our unhandled input. Say elif event is action pressed. And let's just go with click for now. You could use right click as well. I have that bound, but we don't need it. Okay. So what do we do here? We get to make a new command just like we did before. So variable C, but this is not a spin command. Oops, not colon, but equals. This is a move command. So we'll say command move dot new. Okay. And then we could simply add the command, right? Why am I getting error? I have a problem with my elif. Oh my gosh. I put this, I don't know why I put there. I thought I was writing a function, I guess. Okay, add command C. There's one issue. We still need to get that target location. And so what we can do here is once we've created our command, we'll just say C dot, because we know our move command has a target position, equals, and then there's a function in Godot built in so we can get the global position of that mouse, and it's called get global mouse position, just like that. Okay, so now we've set that position. So if we run the game and I click, he moves. Now you can see he moves faster or slower depending on the distance, because it just is, the tween works over amount of time. Really, we want it to be speed based. And so let's go ahead and just replace that duration. Let's create a little function in here. So this is a good example. So you can build more functionality into each of your commands, right? So I'm going to build a function that we just call maybe get duration. And this will return a float. Okay. And how are we going to get the duration? What is the duration that we're going to get? To get this time based off of our speed, we can set our speed, and then we need to get the distance and divide it by the speed, right? So we can return a value here. We'll return our initial position dot distance to, where's distance to? Distance to target position. Okay, so that's going to give us our distance. And then you could have a speed variable. I'm just going to hard code it for now. We're going to say 500. Let's say it's 500 pixels per second. There we go. That's going to give us a duration. How long does it take to go that distance if it's 500? And so now I just need to swap this out with get duration. Just like that. So now if we run it, it should be nice and consistent. There we go. And I'm going to hit S twice, 3 times, and click. And you can see I'm queuing up actions. And they're just showing up down below. And now, because we built this undo, if I say undo, each time I click it, because of the way I built it, I can't just spam click it, right? I just got to wait. But it's undoing each action in reverse order. Now, one thing we didn't do is once it undoes, it doesn't go back up to the command queue. I mean, you could make it do that if you want, but then you'd end up with a queue that just gets never-ending large, you know what I mean? So I don't know if you want to redo and undo, then you got to manage that a little bit more carefully. But there we have it. That's a basic command pattern. Now, there's a lot of things you could do with this, right? You could use it to build, I think what I would most likely use this for personally would be something like a action time battle system like Final Fantasy or Chrono Trigger. But this example here shows how it could be pretty useful for something like real-time strategy. Maybe you're just making an application where you just want the redo, undo, and so building your commands in this kind of a pattern would make that possible as well. So thanks everybody for following along. If you guys appreciate this content and you're new to the channel, please subscribe so you can see what's coming up next. And as always, we'll see you next time.